quadrilateral. It's a trapezoid. So it has exactly one. It's already in a square on your notes, but like underline, highlight, whatever you can do.
One pair.
Exactly one pair of parallel sides. What if it had two pair of parallel sides?
Maybe
No. Then it would be a parallelogram.
That's what it is.
But a trapezoid is not. You found that on your thing this morning. Okay. So in order to be a trapezoid, that means it has one pair of parallel sides. But then that also means one pair of not parallel sides. So when we're proving it, we have to prove both. We still have to look at both sets of opposite lines. Okay. Our trapezoid has two bases, which is confusing because there's a base on top and a base on bottom. But those are the parallel lines. And then just like a triangle, it has legs. So the not parallel ones are legs. Then we also have a special name for base angles, or for the angles. They're base angles, so you have to know those vocabulary words.
All the angles are base angles?
Yes. Okay. So you have this on your notes. We're looking at if it's a trapezoid or not. So how do we prove that something is a trapezoid?
Quadrilateral with one side.
So you need slope to show.
That's
We need two parallel lines and two non-parallel lines. Okay, so we'll start with DE. What's our slope from DE? Just rise over run. How far do you go up?
1 to 3.
Go up 1 over 3.
What's the equal sign?
In case it reduces their slope.
Oh.
For CF, how far do I have to rise?
2.
How far do I have to run?
2, 6.
And that reduces
1, 3.
2. So since the slopes are the same, you can draw a little parallel sign in that blank. We have one set of parallel lines so far.
Yeah.
We look at, says EF next. We have a negative slope, so how far do we rise down?
2.
So negative 2. How far do I run? 2. Negative 2 halves reduce to
Negative 1, 1.
negative 1.
I just said 1.
On CD, our last line, we rise. How far do we have? Number 1, which is just
3.
Are those slopes the same? No. So you say EF is not parallel. So because quadrilateral CDF has exactly one pair of, what does it have? One pair
Parallel
of
lines.
parallel sides.
Oh, parallel.
It's a trapezoid. So what are DE and CF called?
A base.
Those are bases. What
That
about
wasn't fun.
CD and EF?
My legs.
Those are legs. So do you guys remember isosceles triangles? What's an isosceles triangle?
This is an
The
isosceles
base
triangle.
angles are.
So what do we know about an
It's a property
isosceles
of
triangle?
it.
No? Well, yeah, all angles are
Two
cubed.
sides are the same.
2 sides are congruent.
Both plot base angles are congruent.
Good, and the base angles are congruent. Remember, if these sides are the same, the angles attached to them at the bottom were congruent. Why do you think trapezoids are so similar to triangles? It's like a triangle with the top chopped off, right? And that creates 2 more base angles. So just like we have isosceles triangles, we have isosceles trapezoids. Wow. Wow.
So that is one of the properties, is that the base angles are the same, like he just showed. And then we also have an if and only if statement. You guys remember those?
Yeah.
What does that mean?
So it's a conditional statement that's true forward and backwards. Do you remember what name we gave that? Yeah, we used, what's it here? A biconditional statement. Good. That means it's a true sentence forward and backwards.
So I can read this as two separate ones. So if a trapezoid is isosceles, then its diagonals are congruent. Going backwards, if the diagonals are congruent, then the trapezoid is isosceles. So basically what that's saying is that CA is congruent to BD. Congruent diagonals.
So an isosceles trapezoid is another one of those shapes that's sitting straight up, right? And those are
So on our trapezoid, labeled 3A on your notes, we have one of our base angles C. So our other base angle right next to it, what's that going to be?
100.
100, because base angles are congruent. But I'm looking for angle A. Veronica.
360 minus 200 and then you divide by
Where'd you get 360 from?
2. All of the entire thing.
Yeah, quadrilateral, right? All quadrilaterals interiors add up to 360.
I'm dying to use that.
So measure of angle A plus measure of angle B. Not B. Is equal to 160. And since measure of angle A and B, those are both base angles, right? So I can just divide this 160 divide by 2. That's 6. Oh my goodness.
She's recording this.
So measure of angle A is equal to, Ryan? 80 degrees. Alright, so we added what we knew to get JL. But how do we get KM? That's not the one we were looking for. What do we know about our diagonals of an isosceles trapezoid? Oh, it's the same. They're congruent. So that is the same. Oh my goodness. The same as KM. Like you said, real quick. What do we know about our base angles of an isosceles trapezoid?
They're the same.
They're the same, so you can set them equal to each other.
Yep.
So 2a squared minus 54 is equal to a squared plus 27. Subtract an a squared over, add a 54. So we get a squared is equal to 81. Get a by itself.
Just like the Pythagorean theorem, right? If we wanted to get a squared by itself, we square root both sides.
A is equal to 9. Last thing, we have a mid-segment of our trapezoid. So any trapezoid, this will work on. Okay, it divides both of our legs right in half. Just chop it right in half. And from there, we can find how long it is, or if we're given that, we know we can find other stuff from it. So go ahead and circle this on your notes.
Wow.
And I also want you to write it down in a different form. So they're equivalent, but sometimes it's easier to see it. Some people like it.
So half of BC plus AD is the same thing as BC plus AD divided by 2, right?
Yes.
In math, what do we call it where we add 2 numbers up and we divide by 2? Or we add 3 numbers up and we divide by 3? Or we add 10 numbers up and we divide by 10? Yeah, it's average. So this looks like a hard formula, like it's but it's not. It's just the average of the bases. That's it. So if you can remember those few words, the average of the bases, that's all you're doing.
Let's try it. Okay, so we are looking for the mid-segment. So EF equal to, we're going to add the 2 sides, so 8 plus 13.5. We're adding the bases. We're dividing by 2.
Get 21.5 divided by 2.
21.5 divided by 2, which is equals 10.75.
So is that just it?
That's it.
That's it.
Nothing with mine.
What happened in the middle?
What?
Like that.
That's okay. So
That's
just
Try
And
it.
you just add them. Like multiply.
So if we were plugging it
divide
back
it,
into
you
it,
multiply it by 2.
we can
Multiply
do
by 2
16.5
Multiply by 2
is
subtract.
equal to the top face plus the bottom base, all divided by 2. So I can multiply both sides to get rid of that fraction. 16.5 divided by 2.
So you just times it.
Times.
33
Yep.
equal to 25
Minus.
plus EH.
So you just subtract 25 from the 33.
Subtraction po,
You get 8.
EH is equal to 8.
Good job, guys. We did math.